Hi, in this video we'll discuss about custom PySpark data source API, especially how we can use unstructured document like PDF documents to extract text and then summarize those text using Databricks. So we are going to build a custom PySpark data source API. So this is a continuation of the previous videos. Previously I made two videos, which I will give you a link. So there we discussed about creating custom data sources using Python. So now the continuation of that one is that we are going to create a custom data source API where we are going to process PDF document. Okay. So this is what we are going to build today. So custom PySpark data source API for PDF data processing. This is a truly unstructured document. We are going to extract the text and provide a summarization for that one. This we are going to do in Databricks. So we are going to use OpenAI GPT models, GPT-4o mini for this particular use case because it is more efficient and also cost effective. This we can extend this particular solution to production workloads as well because we are doing in Databricks. So you can extend to production workloads with lot of PDF documents stored in the storage, whether it may be in volumes or anywhere where Databricks is able to connect and fetch the PDF. So why it matters? Here, for production use case, especially the large enterprises will be having a lot of unstructured document in the form of PDFs. So that one, if we can able to extract and give or prepare a LLM ready data, then that will be more useful in order to get insights from those documents as well. So a lot of key insights will be buried in those documents, and where either an analyst or whoever it is, they have to search it, or if you want to process in a large scale, then definitely you need a kind of system where it has to do in a parallel processing environment. So that's what we are going to do with the Databricks. Yeah, so that's one key point here. So we get intelligent summaries, and with Spark, obviously, it is a parallel processing. So here we already discussed about PySpark data sources. So what it is and how it can be created. So what we create a data source and we create a data source reader, and then in this especially input partition class we enable to for parallel partitioning, and then we register it, and then that data source reader can be used multiple times wherever you want to do the work like what defined in those particular data sources. So this is native Spark integration, automatic parallel processing, and like just Spark.read.pdf, like you can read everything from that particular volume of data. So I already discussed like how we can create a PDF like a data source, a custom data source API using fake data as well as calling external REST APIs as well. So in this particularly, we are going to create a PDF data source, which returns a PDF is the name of the data source itself, so that while calling, we can call it as read.pdf. So that's one thing. And here, these are the schema I defined in that one. So one is file, page, and text, and summary. So the summary is the AI-generated summary. And who is the author of that particular PDF? Either it may be analyst report or whoever it is. So that also will be captured as metadata and also title. So here this is very simple metadata, but if you want in detail, in-depth metadata also, you can adjust according to your needs. That's one thing I want to highlight here. Apart from that, so we need a reader class. So this is how I built for that PDF data source reader. So we give the path, pages, and if there are tables, you can also extract tables. So here I just confine to extracting tables and summary. You can also extract images, or you can, if you want to get a detailed summary of the charts, you can also do that using a visual LLM. That can also be integrated here, but I go with the basic thing where extract the tables and generate the summary. And we have the choice to choose LLM model. Like you can pause the LLM model based upon the use case. If you want to pause OpenAI models, you can use OpenAI models, or if you want to use Gemini, you can use Gemini. It depends upon your use case, like how exactly you are going to structure the output and what kind of output you are going to extract from those documents. If it is very complex, it depends. Like if you are going for very complex documents where it is visual heavy and you need to convert it to image and all those stuff, then you can use a different model. If it is a lightweight, you can go for a different model. So that's upon depends upon your use case, how exactly you are going to get those. And finally, we are implementing PDF processing. So here I'm using pdfplumber as a library to extract text from the images. You can also use different libraries. Like if you want to go for advanced level, you can use a dockling or a small dockling LLM. So it is purely depending upon your use case, like how you are going to get the output and what kind of output you are going to extract from that one. So that's one thing. And so that's the thing I want to highlight here. So I just use a PDF plumber. It does the work. It's a very straightforward and it does the work. So here it is a page by page processing. So since these documents will be spanning from 100 to 1,000 pages, and we are using parallel processing, and we need to extract all those pages. So that's why I go by page as a processing method, and then table extraction is also there, and also we preserve the metadata for those like which page and which is the author, and also the streaming method I implemented from the LLM, and then summarization. So it gives, if you give a document, it gives a quick insights, like the exact summary of the document. Like there, I didn't give a elaborate prompt. If you see, you can play with the prompt, like how exactly you want to get the summarization. Based upon that, you can play around. I given I will show you in the demo like how exactly I did, so that you will get an idea. So that's one thing. So if you get the summaries, and then from that also you can, because it's already a structured data we have. So then for the downstream processing, if you want to send you to further downstream processing for LLMs or any other agents, then it will be very easy and you can easily able to provide insights. Or even if you want to do retail augmented generation chatbot, then also you can, it's very useful because we already have the data. So this is a simple integration architecture. We have a lot of files, PDF files, using PySpark data source API. We are giving those contents to OpenAI and then get the summaries back. So everything is parallel processing. So each node, depending upon your cluster size and node configurations, you can process a huge low amount of data there. One thing keep in mind, it is all OpenAI. So that's why here I use GPT-4o Mini, comparatively less cost. Again, it is depends upon use case. So if you are going for a much brighter, more elaborate summaries or key insights, something like that, you can choose the different models. But about that, you need to consider the cost as well, where significantly there will be more cost since you are processing a huge amount of documents here. So yeah, so in the part 3 we are going to add a summarization. Like here we are pausing the documents and getting the quick insights. So it's like what I did was, like just I discussed previously, we paused the PDF files and using custom data source reader, and then parsing those things PDF plumber, and then parsing those text, and then getting the insights from OpenAI, everything in parallel because we're using Databricks setup here. So that is the main advantage here. We are using Databricks. So even though I used a single node cluster, but in your case, it depends upon your use case, where you can go for multi-node cluster with a higher configuration, so that you can do parallelly everything and then get those things done quickly and efficiently. So here I truncate long text to 4,000 characters max, because in this demo I just want to stick to a bare minimum, so that I don't want to do any fancy things here. Just I want to show you like how actually it works and how it can be implemented in production like systems. One thing to note here is that I used GPT-4o Mini, but in your case, depending upon your use case, you can go for different models. But keep in mind that these things will cost you. So depending, like you can do a permutation combination, like what kind of thing we can do and how it can be done, depending upon your use case and you can test some few samples, and then based upon that you can tweak those things. So this is the one which I implemented. Regarding security best practice, I already explained that you need to create a scope in Databricks and then put the key, or either you can retrieve from Azure Key Vault or AWS. So that's up to you. So that's one thing here. Yeah, so and distributed parsing. So yeah, so now since we're using the main point here is that we are using everything in a parallel processing environment. So those things will be done parallelly. For that, we need to do consideration like each driver has to do is sorry each executor has to do his job. For that it will be like a separate entity doing those jobs, so that you can accomplish the work in parallel. So you need to adjust the code in such a way that each of them has their own setup, such that it will talk to the OpenAI and get the work done. So we have a driver and different executors. So there those worker nodes should have those capability to talk to API and then get the output. So this is the flow I did. Driver node and then get API key from secrets and set environment variable and register data source worker nodes, and then read environment variable for each and every worker node, and then process PDFs in parallel and generate summaries and return the results. So this is what I explained previously. Now I will show you the yeah. So this is the exciting part, like where we can see the demo. So here I already explained like what are the required packages to install. So I need to install pdfplumber and OpenAI. So pdfplumber we already discussed. This is the one which extracts the data from PDF and then convert it to text. OpenAI, as obviously I'm using OpenAI GPT-4 Mini. In your case, if you are using Gemini, you need to install appropriate packages here, and then we need to restart it. So here my API key was stored as environment variable in a cluster itself, but that is not a right way to do the one. Since it's a demo, I did that like that. In your case, you can either use it as a scope, like as a secret key in a scope, and then retrieve it from AWS or Azure Key Vault. So this is the actual code I did, like creating a PDF data source, and these are the fields I need actually from what it has to, like what we are going to achieve finally. Sorry, it is under detached, but anyway we have the output here. So here the file, what is the file, and page, text, summary, author and title. These are the fields we are going to see as a final output, and we declaring the reader, like creating a reader for that PDF data source reader. And then what else we have? Yeah, so you can give an option like how many pages it need to extract, because I tested with two different documents, and I want to stick to a minimum number of pages, just we want to see, because otherwise the LLM cost will be more. So that's why I gave those options, and I'm using GPT-4 Mini as LLM here to give the summary for that text. That's one thing here, and then using OpenAI. So and then for summarization, here if you see the particular summarize method, I didn't give any elaborate prompt here, like I just gave summarize concisely, that's it. Just straightforward, that's it, nothing more, like what are the things you have to do and how it has to be done. So this is the where you can tweak around, and then depending upon your use case you can give a perfect prompt structure, or else even you can elaborate in such a way that you can give few short examples as well, such that the LLM will diagnose your requirement, and then digest your requirement, and then give you as precise as required. I want to test with a straightforward ask, just summarize concisely, that's it, but that still works well. that's one thing. And then this is a just want to read page by page, and then if there is a table and give the table and all those stuff. So that's one thing, and I'm going to summarize the table as well mentioned here. Okay, so here okay, so yeah, so I registered the data source. So we already discussed how to register the data source in the previous examples. So create and then register it. Once we register the data source, we can use it. So this is what this is how we can use it. So since we already have the option to generate summary equal to 2, even like you can do it without summary as well. Okay, so that can also be done. And then I gave the max pages to 5. So there are a lot of pages, but I want to stick to only 5 pages just to show the output how it is there. And I did for 2 PDFs. One for this one, so big data analytics options on AWS. This is a kind of white paper where it has more than, I think, 70 pages. So here when I ran, you can see yeah, so this is the thing we got. And then if you see here page 1, it give a conscious summary. This AWS white paper on big data, sorry, big data option outlines various services to improve product for processing and analyzing large data sets. So this is the thing it gave from the first page. So let us see, like we go for page number maybe 5. Okay, so with Amazon is client library. So let us see whether it captures these things. So if you go to the last this one, yeah, this AWS one big data to various Imagine quick summary the each section each service product components AWS. Okay, so Kinesis, MSK, AWS Lambda, Glue, AWS Lake Formation, all those things, like, yeah. So ideal usage patterns. Okay, so this is what it getting from this particular page, I think. Okay, maybe it's starting from here. So that's what I think. Okay, let each service provided. Okay, so this is the summary we got from that particular PDF. And the second one I tried was NVIDIA. So this is a bit of complex thing where it has about chart, table, and all those kind of analyst report. This is a very old one. So if you can see here, when it, if we can, yeah, I can. So this is a page 1, and this is a text, like what actually it captured, like it retrieved from that particular PDF. If you can see here, these data are like, even with the pdfplumber, it can able to extract, see, net debit equity ratio minus 34.7. So net debit equity, yeah, see. So these things it can able to extract. We didn't use any fancy packages here to extract, but still that particular pdfplumber can able to extract these things. That's one thing here. And then okay, let me see. Okay, so I think those are the things it can able to extract the table precisely, like what actually it was there in the table. And then for that we have the summary as well. Yeah, this is the summary for that particular thing. So NVIDIA Corporation, a leader in AI and GPU technology, is positioned for substantial growth driven by strong demand for AI applications and cutting-edge data center solutions. The company holds a dominant market share in AI chips with anticipated revenue growth of around 50%. Let us see if there is anything mentioned about 50%. Maybe it is buried somewhere here, we need to read. So that's one thing. And then okay, so buy with a target price of 175 per share. I think this we can find out. 175, yeah, 12 month target price 175 per share, buy. So this is from this particular, like it paused all the text from this previous this is a text which is given to that LLM, and then we got this output here, reflecting confidence in the robust fundamentals of technology advancements. The key risk including increased competition potential. Okay, that's good, fair enough. Okay, so now if we go to the second page, we need to dig deeper, like okay, if we go to the second page, let us see. Oh, okay, we have the financial summary here. I don't know whether it can able to capture it properly. Let us see. I didn't even check. Okay, sales steady growth. Oh, okay, sales steady growth from 26.98 billion, 26.98. Okay, I don't know where it goes. 26.9 billion FY 22 to project 182.2 billion FY 2026, 22 to 26, 26 point, okay, and 182. Yeah, so it can able to capture it, but not the precise number. 26.9 billion, that's correct. 26.9 billion, that's correct. And 182.2 billion, that's also correct. Gross profit of gross profit decrease in FY 2023, then a significant rebound. Okay, gross profit decrease in, yeah, so it can able to precisely get the points, like what actually required from that particular text, and then get the very good summary, like what actually we required. So it precisely pointed out like decrease in FY 2023. If you see here, decrease in FY 2023, and then what it says, and then significant rebound to 135.2 billion. So significant rebound to 135 point, almost 1.6, so 2 billion. So that is so good, like it gave the correct data points, like how exactly it is. So EBITDA declines in FY 2023 followed by strong rise in FY 2026. EBITDA decrease. Okay, see, so EBITDA decrease in, yeah, so that's correct. So this is the one. Yeah, so this one, like if you can imagine, like this is a very basic setup, bare minimum setup with no fancy so-called PDF extraction techniques. With this itself, like, and also I didn't give any detailed prompt. Like if you can able to play with this prompt based upon use case, in my use case, especially in financial domain, if you can able to give a prompt in such a way that you need to do this, that, and a clear instruction. We already know, like if you want to get a better answer, and based upon the requirement, you need to structure the prompt in such a way that you give the instruction clearly and concisely, like what I have to do to the LLM, then it will give you what as required. Here if you see, I just gave summaries concisely, that's it. And also I'm using GPT-4o mini. It is a basic LLM compared to higher, like GPT-5 and all those stuff, especially for for this use case, like, and also it is cost effective. So you can play around and get a quality output from this one. And one thing here is that this is all we are doing processing parallelly in Databricks, and then this will give you way for processing a huge amount of data, especially unstructured data. That's one thing, and you can save it anywhere as in any format, because we are in Databricks, so you can save it in any format, and then pass on to downstream pipelines for further processing. So this is what I want to show to you today. Hope you like this video. Thank you.